Great. So I'm going to introduce our seminar speaker today. His name's Greco, and he's a retired U.S. Air Force Lieutenant Colonel. He spent most of his military career as an intelligence officer, both in the U.S. and overseas, and this was primarily during the Cold War. He also spent some of his military career as an associate professor or assistant professor at Carnegie Mellon University, University of Pittsburgh, and he was a full professor at Wilkes University, and these are all in Pennsylvania. He's given many presentations ranging on topics such as security regulations, technical specifications, and other undergraduate lectures. He's briefed senior-ranking military personnel and civilians, including multiple members of Congress and military general officers. After he retired from the military, Greco started his information technology career in private industry and later transitioned to the U.S. government as a civilian employee, working for both the Social Security Administration and the Department of Defense. He retired from the federal government and started his own business called Greco, and he is now a senior consultant and instructor there. He has many certifications, mostly in project management, some in cybersecurity, and also a graduate certification in applied statistics from Penn State. For the record, Lieutenant Greco is not an engineer, but he has worked as a program manager with a staff of engineers and technical specialists, and he's learned about engineering specifications in order to understand and communicate with engineers like us. He's completed mathematics through calculus and differential equations just like we do, and he's even taken some engineering drawing courses. For the record, Lieutenant Greco knows how to operate a slide rule. His two brothers are engineers. He understands the basic thinking of engineers, and so he tries to avoid it in general. Just kidding. He lives in Baltimore with his wife, Kathy, has two daughters, neither of which are engineers. So yesterday he was in La Jolla, California, where he spoke to the International Conference of the Computer Management Group on cybersecurity, capacity management, and the insider threat. Also, it's Veterans Day. It's no accident that I invited him to come today. So when we welcome him and thank him for visiting us, maybe a little extra round of applause for his service. Please join me in welcoming Lieutenant Greco.
Thank you, Dr. Goodwill. Thank you, students. We'll start right away. So I have to tell you right now that no, I'm not an engineer, but I was involved in the millimeter wave project at the Department of Defense. So back in the 1980s. So I had to learn about millimeter wave, dB attenuation, all those things that I had, and I had no math background at that time, so it was very interesting trying to learn all that, but I had to do it for the contracting arena, so it was very interesting. So I understand where the engineering mental set is, so I'll try to hopefully get that point across. According to my background, which is mostly social science. 35 years of experience in all different types of industries, academia included. So I think that I have a well-rounded approach to project management in general, and I've done enough with technical people to be able to understand a little bit about what they do. All kind of different areas, as Dr. Goodwill stated. Highly technical staff. A lot of times I would understand just enough to be able to communicate with them on their lexicon level, because that was really important to be able to understand the definitions the way they appreciated it. So what is project manager versus project engineer? We'll talk about that real quick. The yin to the yang for the Wright brothers, that's example one. Every single one of these examples, we'll talk about 3 case studies. 2 of the case studies, the people aren't even engineers. Did some unbelievable work in technical arenas. One of the case studies is a mechanical engineer who designed helped design a building for NASA that is still used today. That is just unbelievable. When you see the building, you're going to probably recognize it, but not realize that this individual was one that developed a piece of that building that was absolutely essential for that building to operate. So who thought building a door would be this hard? That's example number 2, case study number 2. And case study number 3, the human who checked the computers. So this will take you back to the 1960s. That's my era. Or I should say my grandfather told me about it. That's me. So, and then any summary or conclusion that we have at that point. So let's talk about the definition of a project. The project is temporary. It has a definite start and end date. And it can be something new, or it can be an improvement to an already existing condition or an already existing operation. So that is our definition of the project. It's well known through the PMBOK, the Project Management Book of Knowledge, that these are the three areas that are really crucial to having a project. So a project manager is responsible for the time and the task, right? The time, the schedule, the work schedule, all those different types of areas. The project engineer is responsible for implementing those technical specs. I cannot tell you how many times I would have never had a project completed without the work of those engineers. Just wouldn't have happened. So I really depended on them to be able to do the work and to be able to come to me openly and express any concerns that they had or any issues they had. And I would take it very seriously. If they had a concern, I wanted to make sure that I abated that concern so that we would continue on with the project. It was very important to me to understand what that engineer wanted, because that would help me complete the project. You're a very important part of this whole thing. The project engineer is the one we'll be discussing today. So these unsung heroes take a back seat, and I've noticed that engineers do this gladly. In most situations, engineers, they develop the product, their reward is it working. That's, it's like, it actually works, cool. My part of that project works. And I see people smiling and nodding. That's exactly right, even in the academic environment. When it works, life is good. Go have yourself another beer. So, man in a balloon. There's a man once in a balloon. I'll tell two stories. One takes a project engineer, one takes the project manager side. Man is in the balloon, and he doesn't know where he's going. He's lost. So he decides to descend and ask an individual where he is. So he descends, and there's a person walking across the field, and he says, excuse me, can you tell me where I am? And the individual looks up and says, you're approximately 30 feet off the ground in a hot air balloon. You're at between 40 and 50 degrees latitude, and 50 and 65 degrees longitude. Man in the balloon says, evidently you're an engineer. And the man on the ground says, yes, I am. How did you know? He says, because you've given me technical specifications, which I have no idea what you just said. I still don't know where I am. So basically, you have been no help to me at all. The person on the ground says to the man in the balloon, you must be a project manager. He said, yes, how did you know? He says, you're going someplace you don't know where you're going. You're full of hot air, and that's how you get that high. And number three is, he says, I've given you all that I know, but for whatever reason, you're still lost, and somehow it's my fault. The wind beneath their wings. So everybody knows about the Wright brothers. I hope. Please tell me. I mean, there were two brothers. Let me put it that way, right? Orville and Wilbur. Everybody knows about them. They are part of our history. First powered flight, 1903. If you don't know anything else from this whole situation, 12 and 120. 12 feet, 120 seconds, right? So that's what, I'm sorry, 120 feet and 12 seconds. Sorry, I get that mixed up. 120 feet, 12 seconds. 12-second flight, that was it. 1903, December. There's a third wing. There's a stabilizer to this whole thing. The two wings, right? You got Orville and Wilbur Wright, and then you got this third person that you probably have never heard of before, but who was a major component to the powered flight actually taking place. If this individual wasn't involved, there would have been no powered flight, and we would not have a Southwest Airlines. His name and history are first case study. Charles E. Taylor. So Charles E. Taylor was born in 1868, and he loved machines. He just loved them. Never went to school for them. Didn't understand the academic aspect of them, never had to tell calculus or differential equations or any of those things, but he certainly understood what a machine was, and he understood how it worked. So, because he loved machines, he would work on different types of machines when he was young. And then he got hired by a place in Dayton, Ohio, a printing shop. And he was just basically printing. But he was so good at fixing machines that they made him basically a machinist. And that's what he did, was fix the printing machine. Well, the Wright brothers heard about this guy, and they hired him. This was after he was a successful machinist and actually had a machining company that he decided to sell. So the Wright brothers brought him in and said, how would you like to work on bikes? He goes, okay, that's cool. They actually gave him some work as a subcontractor, and he worked on that area. But yet, he still sold his company, and they said, we'll bring it at $18 a week. He goes, great. It was 6 miles away from his house, so he could ride a bike to the bike shop. He'd fix the bikes, and that's what he would do. Well, all of a sudden, they started into this kite thing. The Wright brothers started building kites. They started building things. And then they said, Charlie, how'd you like to build an airplane engine? Charlie said, great. What's an airplane engine? So they described it to him. They said, this is what we'd like to have. They gave him sketches, pencil sketches of what the engine should look like. Also, they said basically that can only weigh 200 pounds. And it's got to be a four-stroke engine. And so those were the specs. And it's got to power these two big things they call propellers, and this is what it has to do. So basically, we're talking about a John Deere tractor, right? I mean, so this is what we're having. So this guy builds an engine from scratch using pencil sketches from Orville and Wilbur Wright. That's what he does. He doesn't have AutoCAD. He doesn't have all the things that we have. He's got pencil sketches. He makes a crankcase with 3 things: a lathe, a drill, and hand tools. He makes a crankcase out of that. He takes an 1.5 inch steel, and he drills the crankcase around the sketch of this crankcase. He drills enough holes to weaken the area, and then he pushes it through, and then he makes the lathe. He brings in the lathe, and he makes a crankcase for the first airplane engine ever to take a powered flight. No Diffie-Q. I'm just making that home, right? So what happens is he does that. In 1903, they go out to Kitty Hawk, and they fly this thing. It flies. It does it. 120 feet in 12 seconds. You know what 120 feet is? 120 feet is the wingspan of a 747. That's what 120 feet is, guys. They did that. They're the biggest name ever. So what do you do once you do something that is so unique and so just unbelievably fantastic that you want to try to sell it? Who do you try to sell it to first? Anybody? The government. That's exactly what you do, right? The U.S. Army says, we heard about this flying machine thing, so we want to get some people up there, because who knows what we can do with that? We want to have people up high, so they can do things like look down or do whatever. I mean, hey, we can do that. So the Army decides they're going to do a contract, and the contract specifications happens to match the Wright brothers. So they get the contract. Charlie says, you know something? And I got to take this back a little bit. He built the first wind tunnel. They had to test it. He built the first wind tunnel. Charlie Taylor. Built the first aircraft engine. Charlie Taylor. So Charlie says, hey, I'd like to learn how to fly. Orville and Wilbur says, hey, okay, Charlie. We have to do a lot of things before we get you to flying. So just keep pounding away at that crankcase. We're gonna get you up there. Don't worry. But in the meantime, we're gonna take this Army guy. His name is Thomas Selfridge. So in 1908, Charlie was supposed to get a ride in the airplane. They decide, no, we're not gonna do that. We're gonna take this Army guy because the Army's paying the bills. So we're gonna take Thomas Selfridge. Now Thomas Selfridge is a West Point grad. He's 20 years old, West Point grad. He's a lieutenant. So they said, okay, and Orville is going to be teaching you. So they take him up, they crash. Thomas Selfridge dies. Orville is put in the hospital. Wilbur is he's trying to figure out what the heck happened. Charlie Taylor goes out to the crash site. He does the first aircraft accident investigation himself. He not only does it himself, but he finds out what the problem was. They had put fresh laminate on the propellers, and because of the speed at which they were going, the laminate basically just dissolved. It just came apart, and that's what caused the crash. He wrote it up in a report. They never used that laminate again. So this is Charlie Taylor. No education, just machinist, goes out there and does this whole thing. So this goes on and on. And so finally, he does all these things. He takes care of it. He's an airport manager. There's only one powered aircraft in the north. He's the airport manager for this aircraft. He hangars it. He maintains it. He does everything for this aircraft you can think of. Charlie Taylor. Now, if this is the first time you've ever heard of it, don't feel alone. Not many people know about Charlie Taylor. As a matter of fact, they found him in the 1940s in a home for the destitute. He was broke. He was dying. Somebody found him there, and they raised enough money to put him into a nice home and be able to take him into. So he lived to be 80, 85, whatever it was. And they have the Charles E. Taylor Award now. FAA does for mechanical and engineering. He wasn't an engineer. But boy, I'll tell you, he did everything an engineer does. And he loved doing it. That, ladies and gentlemen, is the first case study. Charles E. Taylor. Let's talk about the next one, case study, the real moonshot. We're talking about the real moonshot. Everyone talks about the moonshot and cancer, the moonshot for this. We're talking about the real one. Right? Apollo 11. Putting 2 men on the moon. Started all the way back in the 1960s with the Mercury. Everything had a reason for happening. Mercury, Gemini, Apollo. And the thing is that was very real to me. I lived through that. I wanted to be an astronaut. Every kid wanted to be an astronaut in the 1960s. Everyone. Everybody wanted to be an astronaut. That was it. Don't ask me why I would want to fly a rocket up there. We all love that. So this is a brief and important story of an individual, an engineer. And this one is an engineer. Mechanical engineer. Graduated from the University of Pittsburgh. Was in the Air Force. Served at places like the Panama Canal, NASA, and the Mercury, Gemini, and Apollo programs, and helped design the element that would make a difference in the entire Apollo program, and is still used today. That is really a neat legacy, is to say something you designed is still used in its original form today. That means a lot to an engineer. Not even a footnote. If I tell you his name, which I'm going to tell you, it just doesn't, you're going to say, who is that individual? You will not forget him after today, guaranteed. This is a link, and I'll be more than happy to give you the slides on this after we're done there, Dr. Goodwill. But basically, this shows what he developed. And if you just, VAB doors, what is that? So we're going to talk about that in a second. So this is the Vehicle Assembly Building, the largest assembly building in the world. These are the doors. The specification for those doors, they were supposed to be able to open and close in 65-mile-an-hour winds. Closed, they were supposed to be able to withstand 140-mile-an-hour winds. Because in Florida, you have hurricanes. You got to make sure and be able to make that happen. In 2012, there was a hurricane, Hurricane Frances. F-R-A-N-C-E-S. Because at that time, they were all named after women. So Frances hit this building, 165-mile-an-hour winds. Doors withstood it. A couple of shingles off the side. That was about it. So this individual, and circled here, his name is Elmer Thomas. And Elmer Thomas helped design those doors. He was proud of those doors. Very proud of those doors.
This individual right here is his sister. Her name was Eleanor Thomas. Later, Eleanor Greco. It was my mother. It was my uncle. So, and the reason I know about this is because he told me about it. And he would send me postcard upon postcard upon postcard when I was in Pittsburgh, because we were living in Pittsburgh at the time, of the different Apollo missions. So I had everything from Apollo 8 to Apollo 12, Apollo 13, all the postcards with the launch date stamped on it. He really wanted to get, and that's the reason I went into the Air Force, was really him. So, can anybody identify this photo?
It might be the Challenger.
You're exactly right, sir. That is January 1986. The Challenger exploded. What's that got to do with Elmer Thomas? So, Elmer Thomas worked at NASA from the 1950s, actually, until 1986. He was 70 years old, and he had refueled the liquid fuel tank in Challenger. When it exploded, he had a heart attack and died. So this means as much to me as it does to any of you from the standpoint of how many people died. Because there's an additional death that was really not recorded. He did die knowing he did not have anything to do with the liquid, with the explosion. So he did die knowing that. But he didn't live much longer than getting to the hospital. So time for a quiz. Who died in the first aircraft crash? Anybody?
Selfridge.
Yeah, Thomas Selfridge. Who was the first to orbit the Earth, and what year did he do it?
Very good.
Who?
Very good.
Well, that's pretty good. But he didn't. That's the first man in orbit. Now we're talking first man ever to go up, and then he went up and down. He didn't do an orbit. So, American Senator John Glenn, correct. 1962. Very good. Who invented common business-oriented language? COBOL. These are kind of just throwing out questions. Women in technology? Grace Hopper, a petty officer in the Navy, invented COBOL. She did it because she was on a ship, wanted to track the inventory. Petty Officer Hopper is now Commodore Hopper, has a destroyer named after her, and the Cybersecurity Center at the U.S. Naval Academy. Not an engineer. Many women go unnoticed that contribute to these areas. Many women. The one I'm about to go on to is the computers who wore skirts. This is in quotes because this is what they called themselves. So she graduated from high school at 14, college at 18, selected to be part of applied mathematics for NASA after graduating. She was African American. There were no schools where she could go. So her parents sent her to an institute called the Institute. And they were able to go between their house, a farm, because he was a sharecropper, and the father was a sharecropper, and make sure that she got the education she needed. Very good at math. Very good at math. Computed the orbital mechanics for Mercury in 1962, John Glenn, and the orbital path for the trip to the moon for Apollo 11. John Glenn asked for her specifically before he got into the capsule to take the orbit. He said, if she doesn't check those computers, I'm not going up. He said that. I'm not going up. And he checked it right before they shut the door. Is she going to check, like holding the door. Is she going to check this? Yes. Okay, thank you. And he shut the door and he went out of the orbit. NASA building named after her, April 2016. First NASA building named after a woman. African American. Her name, Katherine Johnson. Ladies and gentlemen, she checked it with this. I mean, this is the real one she used. But basically, this is what she checked the computer with, slide with. My uncle did the same thing. Oops, excuse me. Elmer Thomas did the same thing. Checked the computers with the slide to make sure it was good. And they would go to her before he would go do every orbit and say, is it good? She'd say, yep. He'd do the next orbit. Amazing. Amazing person. Not an engineer. How much time do I have left, Dr. Gould?
You're doing great. You've got 23 minutes.
Oh, cool. Perfect. Okay, so you have your 3 case studies, right? Charles E. Taylor, not an engineer. Elmer Thomas, engineer. Katherine Johnson, not an engineer. All STEM, though, really, when you really think about it, what they did, how they did it. Okay, some homework. About to show you some pictures, and like I said, I'll give you the slideshow. Basically, the next individual we're going to talk about was an engineer. He did something so impactful in the history of not just his country, which was Great Britain, but also the world, especially during World War II. He had the courage. I mean, when you think of spies, and you think of espionage, and you think of trips undercover, you think of individuals in dark coats, and especially in the 1940s with hats, dark hats, glasses, sunglasses, and they have these. They look kind of squirrely with these little briefcases, and they board, and they know kung fu and taekwondo and all kind of other Japanese and Korean words, and they do all kind of different things that the espionage is part of the deal. Well, this man was an engineer, and they said, look, you've got to travel to the United States from Great Britain. What's the big deal, right? You get on United, here you go. No, this is World War II, so he's going to go by ship. Still, what's the big deal? You're going by ship. Well, you're not only going to go by ship, but you're going to go from Great Britain to the United States, and about every mile or so, you may get torpedoed by a U-2, or by a U-boat. So, what do you think about that? That you're going to get torpedoed. He said, I'm still going. I'm going to go. Took real courage. So he ended up going across the Atlantic during the worst possible time that you could go across the Atlantic in any type of ship or boat with a briefcase. In this briefcase was the work of British scientists. These were designs that were drawn for things like the ability to beat the U-boats. The problem in England was they were getting bombed. They were getting bombed all the time. They could barely keep up with their own industry standards. So they went to the United States and said, you guys have all kind of industry here. Steel industry, aluminum, you have all kind of different areas, different industrial capability. Can you make these things? Sure, give us the plans. We'll make them. We got some research areas, some research sites. So that's what they did. So he carried this on board, went across the Atlantic. I mean, if the Germans would have known this, they would have not just put one torpedo in that ship. They would have put 90. They would have made sure that thing was on the bottom of the ocean with his body on board. Because what happened next was he brought that thing to the United States, and we developed radar from those, sonar from those, all kind of acoustic capabilities from those, because he invented the magnetron. He had the design for the magnetron. You know how you do your Pop-Tarts in the microwave? Would not have been possible without this. So, I mean, all these things, have to do with this guy. I'm not going to give you his name. I think that's unfair. You're going to have to do the research on this. There's the ship that took him across. It was never torpedoed. Was never even bothered by the Germans all the way across. It was in a cargo ship, but very, under Swedish flag or whatever it was. That's him. I mean, ladies and gentlemen, he looks like an engineer. I mean, he's, look. I mean, either that or Teddy Roosevelt, one of the two. So, I mean, he's either one of those. His work is our enjoyment. And, if it weren't have been for him, who knows what would have happened in the war. And it rhymes with wizard. I'll just give you that much. So it has to do with engineering capability Now remember, they didn't have the industrial capability to do that, manufacturing. So they had to do drawings. That's what they did. They brought over all a set of drawings. This wasn't the type of thing you go on Xerox and you make a bunch of copies either. They had like one copy back in Britain. They had this guy with everything else. We loved it. Our scientists just went nuts with it. They developed all kind of different areas. So what I want to tell you about now, and we're done with the case studies and your homework. Sorry about that. So I want to talk to you about two more short cases because they're both military. It's Veterans Day. We have to understand their contributions here. So both died young. One died older, but you know. The first person I'm about to talk to you about died at the age of 23, freshly married. Was in Desert Storm, the first one, 1991. Freedom of Kuwait. The Kuwait freedom aspect, Desert Storm. So this individual was an engineer, University of Pittsburgh, was an electronic warfare officer on a B-52, big bomber. You know, 8 engines, it's huge. And it's still being used today. So his name was Jorge Arteaga. And call him George. They said, call me George. So George was the first person, the first officer candidate that I ever commissioned when I was a member of the staff at the University of Pittsburgh. So he was just young. He was just full of energy. So if I were, how many here have taken stats this far? Good. Okay, good. So you kind of understand this. So probability aspects. Let's talk about probability. There's 100,000 people. And out of 100,000, actually probably more, 200,000 people, 143 died. 143. In the first Desert Storm, that's how many were killed in action. 143. George was one of those. His body was never recovered. They were coming in for a landing at Diego Garcia, which is in the Indian Ocean. And it was bad weather, and they went down. They never found the plane. Never found his body. His father was an embassy supervisor for the Colombian embassy in the United States. He was a U.S. citizen by birth. So that's number one, engineer. The second one was an F-16 pilot. His name was Dan Swain, S-W-A-Y-N-E, Swain. And Dan was not an engineer. He did do, I think, a year of engineering and then switched off. He was a pilot, F-16, like I said. And he was in Desert Storm 1 also. And he was flying what they call a two-ship. So you have two F-16s flying side by side. They had to go up to the tanker, the KC-135 tanker. I mean, think of all this with Charles E. Taylor, right? I mean, none of this would have happened. So you have the tanker comes down and it refuels the aircraft, and the aircraft can go back off and they can do whatever they want. At that time, in the 1960s, we were the only ones that had air-to-air refueling. I mean, so this is now 1991. So Dan and his lead, what they call the lead, were taking a drink of fuel off the tanker, and Dan all of a sudden hears on the radio that some Green Berets were stuck, and they were getting basically just slaughtered by Iraqi forces. So they pull off the tanker. They weren't done, so they only had a little bit of fuel left. And I asked him to explain it once to me. I said, what was it like? He says, the scariest thing in the world. Because when you're flying, he says, we're painted a gray, and it's very hard to detect us in the background because of the way the paint is. When you come down under, especially when it's overcast like it is today, they can detect you right as you're coming down off that overcast. So you're like a sitting duck to any surface-to-air missiles or any even small arms fire. So they're coming down, he's coming down, they strafe the area, they save these Green Berets. He gets the Distinguished Flying Cross. And as a result of it, he ends up, the lead gets a Silver Star. So what happens after that is that he loves flying, he takes flying very seriously, he instructs different foreign countries in the F-16, because that's what he liked to do. He just died about a month ago, instructing instructing a foreign pilot, and the pilot lost control and he died. So, I mean, both these individuals, one not an engineer, one an engineer, that are very important from the standpoint of victories in Desert Storm. So you never know where you have an impact, whether you're an engineer or not an engineer, correct? Or how you're part of that project engineering aspect, even though it may not seem like a project. So that, in summary, your work as an engineer doesn't just impact that project. It impacts the next project, and the project after that, and the project after that. It takes creativity. You have to think past all that you've learned from the standpoint of formulas. You got to think up here. Think, this outside-the-box thinking. I always use a baseball. You don't just want to think outside the box. You want to think outside the park. You've got to think of things way beyond what seems to be rational. And then you'll be able to impact a lot of different things. So you're going to work with project managers. Some are better than others. Some will demand things of you, and you'll sit there and say, this is not possible. Explain it to the person why it's not possible. A lot of people just walk away and shake their heads. Explain it to them or her. It makes sense. It may make sense after you explain it to them. But creativity and innovation is your friend. If you don't have it, nobody else is going to give it to you. You've got to get creativity through your work. So let me tell you about project manager, who was an engineer. So this individual had to count had to track whale sharks. Whale sharks are the biggest sharks in the world, usually located in the Gulf of Aden, around the coast of Africa, and they have a set of dots on their sides, like fingerprints. So the individual, they said, oh, you got to track these. This is your project, track that. And the project engineer is sitting there saying, how am I going to do it? He's thinking, he's looking up at the sky at one point. And all of a sudden, it comes to him. He calls up NASA. He says, do you guys have star tracking stuff? And I said, yeah, we do have star tracking stuff. He said, what about if I change the background to gray? Can you still track the stars? He said, sure. He said, can you send me the algorithm? And he said, we'll send the program. He sent the program, set it up so that they took pictures of the whale sharks, and then they plotted with the star tracking, star charts, and figured out exactly which ones were distinct. And then they were able to track it. They still do that. It's stuff like that. Just, black plastic balls, right? Environmental engineers. Black plastic ball, or black, whatever it is, non-plastic balls or whatever it is, thrown into the reservoir in California to prevent evaporation. Thank you, yes. Yes. Black plastic, what? I mean, who would have thought black plastic balls would be that important? So that's what I'm saying, just simple little things. And that's what creativity will do for you. You want more information? Go to NASA, look it up. Go to FAA, look it up. Go to this one, and you can even find out, if you look real quick before I change it, what the guy's name was. I changed it. So that's this is my contact information. I do have business cards if you want it, if you want them. Are there any questions? How many?
We've got 10 minutes for Q&A. Let's thank our speaker, though. That was great. We have 10 minutes for Q&A, and then also Colonel Greco said he's going to make himself available in the student lounge, as some of our other seminar speakers have done. So if students would like to ask follow-up questions or maybe just chat with him about career paths or project management or project engineering, he's happy to do that too. So any questions right now?
So before you leave, before there's any questions, I want to present Dr. Goodwill with something. So remember we talked about Elmer Thomas. We talked about all that he did. Well, I happen to have, because I found it actually, was a, we call it a caliper. Thank you, dear. It's my wife, Kathy. So, so this is a caliper that he used. So what I did was I put this in a box, and I'm going to give it to Dr. Goodwill. It's called the Highest Caliper Award. So I'm going to give this to him. He can use it as he sees fit, but this was in fact used by my uncle, when he was doing things, before computers and stuff.
So I did have a little bit of a tip that this might be coming, and I haven't quite thought through a plan. I've talked to Dr. Bill and some other folks about this, but we're somehow going to incorporate this into an annual award of some flavor that we give one of our engineering students. So you'll be seeing this again. It'll stay in the university. Yeah. So we got about 7 minutes for Q&A, and we also have follow-up informal chatting in the lounge. But are any questions right now?
Yes, sir.
Whenever you use the star tracking, did they take a picture of the whale and use it on the spots, or the whale in the background of the ocean?
No, the whale is actually gray. So yes, they took a picture of the whale.
Okay.
So they had to get underwater photographs of all the whales that were in that area, and then make sure, and then use that as kind of distinct, and then just kept tracking those whales. So they found out their migrating periods and all that stuff. It's really pretty cool. So, any other questions?
No, but
Yes, sir.
I got a story for you about dealing with project management.
I'll bet. I have no doubt. I'm sure the engineers I work with have that.
I was working with Comset at the time. We were building something for NASA at the time. And we had a project manager. We tried to tell him that the mil spec he was imposing on us was a storage spec, not an operating spec. He didn't understand the difference between the two. So what we did is we invited him up to Raytheon to an environmental chamber. And we put him in, he came up in this nice suit. He said, we're going to put you in the chamber and we're going to run it up to the temperature and humidity that you want us to operate in. But if you're uncomfortable, come on out. So we got it up to a point where his tie was loose. When he opened the door, it rained. He came out soaking wet, and his response was, what do you want? That's the only way we could get his attention.
Let me tell you, as long as you don't put the project manager's life at risk, have at it. I mean, just have at it. I can't tell you how many times where an engineer would sit there and say, you want this? Fine. Put your finger in that hole right there, and when you start to scream, we'll stop. It was okay. Never mind. We'll move on. No, thank you for that.
Any more questions? All right, so we'll do the informal chat. I'm going to ask one question, though.
Yes,
so you've had a really diverse career, started your own company, military, federal government. Based on that experience, what can you just offer any general advice to this group of students who might be pursuing a career in engineering? Is there any particular skill, or other than the ability to think outside the box, as you mentioned, outside the ballpark?
So there's a story that I will tell, just to finish this up, and that has the engineer and the project manager, right? So now we're going to take the man in the balloon thing, we're going to switch this around a little bit. So there's an engineer out there who is trying to uncover a pipe. And he is just, doing all kind of stuff, figuring out the little sextant thing and, angles and all the other stuff. And he goes to the project manager and he says, okay, I want you to dig right here. And this project manager's kind of old. He goes, look, I don't know if you really want to dig there. Say, whoa, I'm the engineer. Do you know how to work this? No, I don't know. Do you know how to, no, I don't know how to, do you know the technical specs fit? No, I don't. Dig right here. All right, dig. So they dug, there's nothing there. The pipe is never uncovered. And the engineer is just beside him. I don't understand what happened. What's going on? And the project manager says, look, I think we got to dig over there. And the engineer finally asks the right question. Finally. Says, why do you want to dig over there? And the project manager says, it's because that's where we buried the pipe 20 years ago. The thing you got to ask is there any information I need to know that is already existing before I go off and do my own thing? Once you get that legacy information, then work your magic. Because you guys have magic. Let me tell you, it's amazing what you guys can do. So you work that magic with the information that's already there. Do your research. That's what I
All right, let's thank our speaker one more time.